So today I want to talk a little bit more about the sig figs. Now that you're getting pretty good at them, I want to talk about why sig figs. I had mentioned that sig figs have to do with precision, and if you have something that's more precise, it usually costs more money. So I'll show you some examples of what I'm talking about here. These are right from the catalog, Flynn Scientific, which is where we get our equipment from. You can see here that this scale reads to the precision of zero point 0.1 or the 10th, and that scale costs $112. If I want an analytical balance, which by the way reads out 0.0000, that's going to cost me a lot more. So in other words, I have to pay for my sig figs. If the answer is 3.2 or something weighs 3.2, I've paid a lot less than if something weighs 3.2921, right? So I have to find a way to tell people that I've paid more for my answer. I always say to you, when you're adding things together or subtracting or multiplying or dividing, it can only be as precise as your least precise instrument. So if you look here, here is a plastic base 10 milliliter right here. It costs $5.55. If I use this glass 10 milliliter, it actually has more markings on it. It's more precise. It costs $15. These are actual decisions that I have to make when I'm ordering stuff for you. Do I order you the $5 one that you're going to break, or do I order you the $15 one that you're going to break? How important is this precision to me? Here's one more little example. You can do the same thing here with a ruler. A ruler has markings to the nearest millimeter. This is just a 95-cent ruler. But if I want to get more precise, I can use, this is a caliper or a micrometer. And this micrometer has a precision that goes out an extra decimal place. You can see how much more that costs. Okay, so as you could probably guess, we're going to be talking a little bit about measurement here. And we're going to be looking at all of this stuff on our measurement utensils, whatever they are, rulers or uh, graduated cylinders or whatever it is. So we have a rule in chemistry, okay? The rule in chemistry states that you must read your instrument 1 decimal. Oh my gosh, I don't know how to spell decimal. Past the precision of the instrument. And the reason that I wasted all that time writing that down is that it's a very important thing when we look at chemistry, and this is why the sig figs exist. So if I were to use a ruler, and this is just kind of an ugly ruler, but if I were to zoom in on that ruler, obviously I'm zoomed in here, and I were to look at how long this black box is, okay? I could say that this black box is somewhere between 1 and 2 centimeters long. But I can say even a little bit more precise than that. This black box is 1.5, 1.6. So this black box lays somewhere between 1.5 and 1.6. But the rule says I have to read 1 decimal past the precision of my instrument. The precision of my instrument is to the 10th place. That would be 1.5, 1.6. I need to write on my paper that this black box is 1.5, and then I need to estimate the last place. And so I'm going to say, I don't know, 1.58 centimeters, which in turn is going to give me 1, 2, 3 sig figs. So that's where that came from. Let's look at an example of a graduated cylinder. This graduated cylinder is for measuring liquids. Now, you may have learned that you need to read to the bottom of the meniscus, is something that you learn in science class. So here's a meniscus. The water kind of goes like that. You're always supposed to be reading to the bottom of the meniscus. So if I look closely here, you can see that I've got 40 to 50, and each one of these markings is for the ones place, 41, 42, 43. Okay, so it's a little bit different than that ruler I was just looking at. My instrument reads to the measurement of ones. The precision of my instrument is 1, and I'm landing, it looks like I'm honestly right here on 43. But the problem is that 43 would be reading only to the precision of the instrument. I have to read 1 decimal past the precision of the instrument. Now, believe it or not, I think that this is exactly on the 43, so I have to write this. So you were wondering maybe where did that come from when you were doing those problems and they had 0.0? Why would anybody ever do that? This is why, because I'm showing you that the precision of this instrument is exactly on 43 milliliters. We can read, here's some kind of real life examples, and I realize that the angle is kind of screwed up, and honestly, it's better if you get the practice for me. So these are 2 graduated cylinders. This one on the left-hand side is more precise than this one on the right-hand side. You can see this one goes to 6 milliliters and 7 milliliters, 6.1, 2, 3, 4, 5. And this one reads 50 to 60, so 51, 2, 3, 4, 5. So this one is precise to the ones, and this one is precise to the 10th. And when I write that down on my paper, I need to reflect that I'm using a different instrument to measure these. So this one is 6 milliliters, and it looks like I'm right there between 6.4 and 6.5 if I'm reading to the bottom of this meniscus. So I'm going to write 6.4, and then I'm going to estimate the last place. And the last place here, I don't know, 6.47 milliliters. This one over here is a little bit different. I'm somewhere between 52 and 53 milliliters. So I'm going to write 52 points. Sure, I'll go with 8 milliliters. You can see that estimation one. You might put 52.7, you might put 52.8, but what you can't put is 53 because that would be wrong. Unless you put 53.0, then you could possibly make an argument there. All right, so you can see here, these both have 3 sig figs, but if you were to do addition subtraction problems, this has 2 places after the decimal or goes to the hundredths, and this one only goes to the tenths place. 1 decimal past the precision of my instrument. We don't use these very much. This is kind of an old school scale, but I just wanted to show you, you can do the same thing with these. We now use electric scales or balances, so you just write down the number that you see. But if you were using one of these, look at, here's your precision. You read 60, there's no hundred, so it's just 62 point, it looks like it's exactly on the 4, so you would say 62 point maybe 4, I don't know, maybe it's a hair above the 4, maybe 4.1, and that would be grams. So again, exactly the same thing, 1 decimal past the precision. Here's a good way to look at precision with 3 different rulers. So this ruler is less precise than this ruler, okay? So in example A and B, they're showing you there is a wooden block and it is the same length, but when you have a more precise instrument, you know more about it. So in this example, I might look at this and say, I don't know, it's between 4 and 5, it's 4.5 centimeters. But then when I look at this example, I see, well, it's looks to be above the 4.5, but below the 4.6. So I can actually write 4.5, I don't know, maybe 7 centimeters. So you can see there that this block just got measured more precisely when I looked at it on a different ruler. This example is meant to show you when it's right on something, you can't just write 3. Again, you need to write 3.0, which feels a little bit funny at first, but hopefully it's making a little bit more sense to you. These are tricky to see here because my thing is blocking it, but you can see that the one all the way to the left is precise again to the 10th, and the one in the middle is precise to the 1 place. So the one here that's precise to the 10th, I would say it is 5 point, this is 5.5, 6, 7. So it's somewhere between 5.7 and 5.8, so maybe 5.73 milliliters. This one I guess, I mean, I don't know where we're reading the water to, but I'm going to go with 3.1 milliliters. And then this guy, this is one of these, we kind of like suck it up with a pipette is how these work. This goes from zero point 0.3 to zero point 0.4. So I actually read it 0.03, but then I have to estimate that last place, 5 milliliters. So a little bit different.